Hello, this is DVB. I tutor logic and philosophy. Today we're going to talk about a logical shortcoming of Craig's Kalam argument, the pure version of it, and what we can do to fix it. So throughout this video, I'll be using these inference rules. If you've had a class on logic, they should be familiar, at least if you've taken a class that covers predicate logic. Some unusual ones would be contradiction, introduction. The idea is the upside down T refers to or denotes a contradiction. And the rule says that if in a subproof you've established P and you've established not P, you can go ahead and put in the subproof a contradiction. And our form of reductio ad absurdum will be called negation introduction, and this says that if you have a contradiction that follows from a sentence Q, then Q has to be false. Okay, so I'm going to be using these inference rules by name, and if you're not sure about the inference rule and you want to go you want to go check out what I'm talking about, you can go ahead and come back here and take a look. All right, so on to the Kalam. Okay, so the pure Kalam has two premises in the conclusion. The first premise is that anything that begins to exist has a cause. And then the second premise is the universe began to exist, and the conclusion is that the universe has a cause. So the idea is that the Kalam tries to reason about the universe, some facts about the universe, and try to show that there's something that's the cause of the universe, and ultimately that something will be God or something like God. So let's go ahead and formalize the Kalam. We're going to have some predicates, so let x is B just means that x begins. And then we'll have x is the cause of y. That just means x is the cause of y. And then we'll also have u, which is the name of the universe. So u just is the universe. Okay, now with these predicates, we can go ahead and formalize the premises and the conclusion. The first premise goes like this. So that says in logician's English, for any x, if x begins, then there is some y such that y is the cause of x. The second premise is simply that the universe begins to exist. And our conclusion is that something is the cause of the universe. Let's go ahead and show that, in fact, from our inference rules we saw earlier, the conclusion follows from the premises. So from the first premise, it says that for anything, if it is the cause, or it begins to exist, then there's a cause of that thing. Well, if that's true for anything, then it's also true for the universe. Therefore, if the universe begins to exist, then something is the cause of the universe. We got this from P1 and universal quantifier elimination. Okay, well, with premise 2, that's the antecedent of the first line. So it follows that something is the cause of the universe. We got this from 1, P2, and modus ponens. And to get the line 2 to look like the conclusion, we have to make 2 more steps. So we can infer from 2 that some anonymous object, call it A, is the cause of the universe. We got this from 2 and existential quantifier elimination. And then we can go ahead and infer that some X is the cause of the universe. We got this from 3 and existential quantifier introduction. All right, and that's just our conclusion. So we've shown, another way to put this is, we've shown that from P1 and P2, it follows that C1. And that's because our conclusion is C1. All right, so one might worry though, suppose that you think that the premises are true and therefore the conclusion is true. Are we committed in believing that there's not just the cause of the universe, but that the universe is distinct from the cause? That there's something other than the cause? Or sorry, something other than the universe that's the cause? So we can put, we can say this. We can say, is it the case that from P1 and from P2, it follows that C2, where C2 is the thesis that the universe so C2 is not just that the universe has a cause, but that in addition to that, the cause is not the universe. And the idea is if you're not a theist, you can say, well, yeah, I agree to premise 1 and premise 2. The universe began to exist, and anything that begins to exist has a cause. And so I believe that the universe has a cause, but it doesn't mean that I believe there's anything other than the universe. So if it doesn't follow from these two premises, then it's no big deal for the non-theist. So that's our question. Is it the case that from P1 and from our premises, we can conclude not just the universe began to exist, but that the universe has a cause of its existence, but that the cause is distinct from the universe itself? And I'm going to show that, in fact, this is the case. That is, it doesn't follow from P1 and P2 that the universe has a cause and that the cause is not the universe itself. So how am I going to do this? Well, I'm going to, we'll say here's our proof. Let's suppose, for sake of argument, that in fact P1 and P2, it follows from P1 and P2 that C2 is true. And let's go ahead and formalize C2. It'll be, there is some X such that X is the cause of the universe, and whatever is the cause is not the universe itself. So let's suppose that in fact C2 follows from P1 and P2. Well, by the soundness theorem, the soundness theorem has it that if C2 follows from P2 and P1, then it's the case that C2 is a logical consequence of P1 and P2. So the single turnstile represents that it follows from the premises, and the double turnstile represents that C2 is a logical consequence of P1 and P2. And how we got from this to this is that that is a consequence of the soundness theorem of classical predicate logic with identity. So what does it mean to say that C2 is a logical consequence of P1 and P2? Well, this just means that there is no logically possible situation, we'll call it a model, So what's a model? A logically possible situation in which that model or that situation satisfies P1 and P2. By satisfy, I just mean that P1 and P2 are in that model, and it's not the case that the conclusion C2 is not true in that model. So what we do then to show that C2 is not a logical consequence of P1 and P2 is to show that there is a model in which P1 and P2 are satisfied, are true in that model, but that model does not satisfy C2. So we do this by drawing a picture. So let M be our model. It's not a very pretty line. Let M be our model. And let's have, as an element in our model, we'll have A. And we'll stipulate that A is the universe. So let's say that A begins. So B is a predicate, begins. So let's say that A is in the set of things that begin, and it's the case that A is identical to itself. And let us say that A is the cause of itself. So if we were to do the math, in this model satisfies P1. Why? Because anything that begins to exist has a cause. So A begins and it has a cause, namely itself. And this model also satisfies P2. Why? Because A, the universe, is in the set of things that begin to exist. But in fact, it does not satisfy C2. Because even though there's something that begins to exist, there's nothing that begins to exist that is not identical to A. So keep in mind here that B is not another element, it's a predicate letter. So, in fact, it's not true that C2 is a consequence, a logical consequence of P1 and P2. And therefore, by the soundness theorem, it's not the case that C2 follows from P1 and P2. So, how do we rectify this situation? Well, we do so by adding another premise to our argument. We can say that let's have a new premise, P3, nothing is the cause of itself. And so our new conclusion will be C2. Something is the cause of the universe, and that something is not the universe itself. Okay, and the proof will proceed just like before, but with some additional steps. So from P3, we can infer that for anything, it's not the cause of itself. We got this from P3 and quantifier elimination, or quantifier negation. And from 4, it follows that the universe is not the cause of itself. So we got that from 4 and universal quantifier elimination. And now we can go ahead and suppose something as a means to show that it's not true. So suppose that whatever is the cause of the universe, we've called it A in line 3, whatever is the cause of the universe, suppose it is just the universe itself. So suppose or assume for negation introduction. Well, if it's the case that whatever is the cause of the universe just is the universe, then in fact, given 3, we can go ahead and put, if A just is the universe, it follows from 3 that the universe is the cause of itself. 3 says that A is the cause of the universe. Our assumption in 6 is that A is the universe. Therefore, it follows that the universe is the cause of the universe. We got this from 3, 6, and Leibniz's law. All right. Now we have a contradiction, though. Premise 5 says that the universe is not the cause of itself. But premise 7 says that it is. That's a contradiction. So from 5 and 7, we can infer that a contradiction follows from our assumption here. And since no contradiction can be true, we can go ahead and infer that whatever brought about this contradiction isn't true. We got this from 6 through 8, negation introduction. Well, from 3 and 9, we can infer their conjunction, that A is the cause of the universe and A is not the universe. And we got this from 3 and 9, introduction. And then finally, we can now say something is the cause of the universe. Some x is such that it is the cause of the universe, and whatever that x is, it sure isn't the universe. We got this from 10 and existential quantifier introduction. And that is just our conclusion. Whoop. So, we've shown that with just premise 2 and premise 1 of the original Kalam, you can't show that the cause is distinct from the universe. In order to do that, you need some premise, and the one we picked is the intuitive idea that nothing is the cause of itself. And then from that, we can show that not only the universe has a cause, but that the cause itself is not the universe itself. All right, I hope you've enjoyed this video, and I'll see you next time.